So we look at another reduction formula that involves natural log of course involves raising it to the power n, ln to the power n of x dx. Okay, so we will know to say for reduction formulas we have to be first of all be familiar with integration by parts. Okay, so at this point it's just a matter of us choosing which one is going to be our u and which one is going to be our dv. And of course, as you choose, there are times when we can't really follow this order, because let's say you only have trig functions. Let's say you need to use like you have two trig functions that are multiplying each other. Let's say you have a tan, for example, like when you find the reduction formula for tan to the power n, we have tan n minus 2 as well as tan squared, of course x there. So you have two trig functions there. So it's not always that you have to follow this order. There are times when you can choose any of them as your u and the remaining as your dv. So it's just a matter of knowing to say which one is going to be easier for you to differentiate and which one is going to be easier for you to integrate. Okay, but in this case, we'll go with our u being the natural log. Of course, following that order, we're going to say our u is equals to um, ln to the power n of x. Then our dv will be equals to our dv is equals to 1, and that's simply the x there. So meaning our v will be equals to what? Our v will be equals to x, because when you find the derivative of x of in this case we say the derivative of v with respect to x, the dv dx, you find what is what? It's 1. That's why you find that our dv is equals to what? Is equals to dx, meaning our v is equals to x. So in this case, finding our du, okay, we're just integrating we're just differentiating what we have here. And what happens in this case is that you're going to drop the power, of course. You're going to have your n in front here, okay? So that will be your ln n minus 1. You have your x there, dx, then divide by what? Divide by x. Okay, so by integration by parts, you're going to multiply your v by your u. So it's x multiplied by ln of n to the power n x there, minus the integral of v du. Okay, so you're multiplying this v by this du, and we have x there on the numerator. This x can go and that x can go because I'm multiplying them. So I remain with what? With my n here, ln of n minus 1 x here dx. Okay, so what this is that I'm going to have my x ln of n x here minus integral of, or maybe before I do that, I can bring this outside because that's just a coefficient. I have my n here, integral of ln of n minus 1 of x dx. Okay, and this ends up being the reduction formula that involves natural log. So we can say the reduction formula for for integral of ln of n x dx is simply equals to x ln of n x here minus n integral of ln of n minus 1 x dx, and that's how simply you go about it.